Hi everyone, welcome to this first Lifting Solutions Group webinar, first one about steel wire rope. There are many more to come, but my colleague Alain will tell you more about that later today. And said today, Alain Bouwman, our steel wire expert, will tell you more about the basics of steel wire rope, about constructions, rope lays, applications, and some practical examples during the 40 minutes to come. Some house rules before we start as well. Your mic is on mute. If you have a question, please send in by chat. And at the end of this session, we'll have a short Q&A session. And I don't think all the questions can be answered today, but we will send you the answers by email after the webinar. This webinar will also be recorded, so we will send the report after that to you as well. And enjoy this session. And before I go to Alain, I have a short introduction about our company, our group. We're part of Lifting Solutions Group, which is a privately owned industrial group that acquires and develops companies in mainly industrial niche markets. And as you can see, they have 6 strong business lines, and we're the biggest one on the left. We're in the Lifting Solutions Group, and I'll tell you a little bit more about that. And we operate as a group of companies with a strong local brands and presence, and I do think that you all can see one of the logos that you will recognize from your local company or you have done business with. So this is the one. And I have one slide to go, which is this one, which will tell you that this is our European footprint. As you can see, we have a coverage in almost every country. 17 countries, we have 22 companies, and as you can see, 1,400 employees. This was just a short introduction for me. I will hand over to Alain Bouwman to tell you more about the basics of steel wire rope, and enjoy.
Well, good morning, very warm welcome from my side. I'm Alain Bouwman. I'm from Belgium. I am an industrial engineer chemistry, and now I'm doing the last 36 years steel wire ropes. So that is another story. We can talk about it later. I'm at Manus Belgium since 1986. They tell me I'm the senior wire rope specialist. Well, I give advice to people. We do a lot of investigations. We want to try to serve our customers with the best possible solutions for their wires, to have the best service life for their applications. We have our own special lab to do investigations from a wire who are discarded or dismounted, and then to advise, let's say, people. Yeah. Okay. Welcome to the world of steel wire ropes. I have some remarks in front. Steel wire rope is a consumable. That means that it has a certain lifetime, and then it will be a rope which is fatigued, which has wear, which has some wire breaks, and then you have to put it out of service. You have to replace it. Huh? It is really a spare part, let's say. Huh? And I sometimes compare it with a roll of toilet paper. Yeah? If you go to the bathroom, to the toilet, it depends a little bit. Do we have enough of toilet paper on the roll there? Yeah. Am I going to have enough paper? No? And is there going to be enough paper for the guy who comes next to my visit? It all depends on the frequency. Let's say, is this a toilet at home or in a restaurant or in school? It all depends on how many toilet paper you need. It also depends on how many leaflets everybody's using in one visit, or the quality of the paper, in how many layers, or the thickness, or I don't know, the color perhaps, or the perfume. Yeah? And how many meters is there on a roll of toilet paper? Or the price, who bought this toilet paper? Did you look at the price, or did you look at the quality, or was it, I don't know, in a discount or something? You see, so to end up, how long this toilet paper roll will last, for how many people, and if everybody is satisfied, well, that's the same idea about steel wire ropes. In 80 or 90% of the problems I have been solving, it is normally not a problem of wire rope, but it is a problem of the installation, or of drums, or grooves of sheaths, or just a bad choice of wire rope for that kind of application. Well, to be honest, if you start with a good wire, you're going to end up with a good wire rope. If it is manufactured the good way with let's say, good machinery, then you won't have a problem. But one thing for certain, if you start with a very bad wire, you're going to end up with a very bad rope also. So that's why I started with these remarks. Okay, you saw here in the picture some applications of wire rope. It can be a thin wire rope or a much bigger one, like we did for dredging companies, like you see here. You know, we have in Belgium rather good and big, world famous dredging companies, so we're doing a lot of advice there. Okay, applications of steel wire rope. Well, I just added here some things you have to think about when you're using wire rope. Sometimes there are high temperatures involved. Sometimes you have environmental with acids. You have to take care of corrosion in water applications or at sea. You need some rope which can withstand high pressures. There will be rough treatments and high speeds and shocks, like you can imagine on container applications, container cranes. Yeah, you have a lot of frequencies bending over drums, sheaves for, I don't know, a million of times. Yeah. So to specifying the best type of rope you need, you're gonna do the calculation how much strength you need. Yeah. In certain applications, you have a safety factor to respect. That's depending on application, overhead cranes, or let's say on container cranes, elevators have a different safety factor. Sometimes the rope has to be very flexible. You need 6-strand, 8-strand, flexible cores or not. You need to take into account the abrasion resistance, crushing from ropes on multi-layer drums. You have to consider fatigue. Anytime rope will get fatigue in the end. And some ropes has to be rotation resistance for high cranes. You have to take care for some fleet angles and non-rotating ropes. Yeah. So they asked me to give you a basic webinar, a basic seminar for ropes today. So it's going to be basic. We're going to talk about tensile strengths, different constructions, rope lace, left and right. I'm going to explain later. Practical applications. I'm going to give you a clue for the high performance ropes, which will come later in another different seminar. And then it's up to you. If you have questions, you just put it down, you do it in the chat, and we will see what will come in. And then colleague Michel will look into that closer after my presentation. Okay, let's talk about wire rope, how it's made. To start, wire rope, steel wire rope. Well, these are the different type of ropes, of wires we can use to build up a wire rope. Yeah. Start with bright wires, that's ungalvanized, that's just the normal wire you can buy and you can make your rope out, but in 90% we now use galvanized wires. This is a bright wire which a zinc coat drawn, and then from these galvanized wires we make steel wire rope. There's another kind of rope wire, and this is stainless steel wire, inox stainless, Well, we're not going to talk about stainless steel wire ropes this morning, because you see there you have about 25% strength loss compared to galvanized or bright wires. It is 7 times more expensive, so take care of prices. And there are limited numbers of constructions in this kind of stainless steel wire ropes. So I would advise it only for applications where there are very high temperatures. We're going to speak not about temperatures, but if you use galvanized wires and bright wires, you can go up to 200, 250 degrees. Everything above that, then you could use a stainless steel wire. So they can go up to temperatures about 500, 600 degrees in special stainless steel wire applications. So you normally see it only on yachting boats, let's say for your boats in Monaco, or in some architectural projects, greening projects for on walls, or I don't know, very beautiful architectural projects. You can use it for slings, but normally in hoisting, you're going to use standard galvanized wires. Okay, for tensile strengths, I can tell you that from the factory you can have different kind of tensile strengths. This is explained in Newton per square millimeter. So there are nowadays 4 types of grades of different strengths in wires. You have the wire 1560, 7070, 9060, and 2160 Newton per square millimeter. That means that if you have a steel wire, you can produce it in all these different kinds of tensile strengths. So you're going to end up in the same diameter with one rope, which is stronger and much stronger. And if you manufacture it in wires of 2160, you're going to have in the same diameter the most strong rope. But price will go up, strength will go up, but take care, your hardness will go up too. And sometimes it is a disadvantage to have a very strong rope, but also a very hard rope, because it's going to wear out your sheaves or your drum. So you're only going to need really 2160 if you really need the strength to have a rope which is so strong. Yeah. All these wires, they have to be known to the regulations you're going to see there in the ISO normation or European normation. They have to have minimum values for strengths, for diameter. They're going to be tested for minimum bending cycles or torsion cycles. And if it is galvanized wire, yeah, then there is a certain toleration on thickness for the galvanization. So we don't care about that. It comes out of the factory, and then the factory will make a steel wire rope. Let's explain a little bit about how this whole process from wire comes to steel wire rope. You see, everything starts at the steel mill. They produce in the rod mill, let's say rods of round wire. From 6 to 9 millimeter, and then in the rod mill we're gonna do a cold, tough roller drawing. So we're gonna make wire thinner and thinner and thinner between rollers. Then you see it's gonna be tested, and then we do a heat treatment. It's like the blacksmith, yeah, who's heating up, let's say, steel to get it stronger and to give it better properties. Yeah, after the heat treatment, we go cleaning, and then we go to the initial drawing. So then we're gonna put the wire to thinner and thinner and thinner diameters. And then if you need a galvanized wire, then you do the galvanization. So you put a little layer of zinc on the wire, and then afterwards, yeah, you're gonna do the final drawing. So with the zinc on it, yeah, you draw the wire to thinner wire and thinner wire till the diameter you really need. In the 70s, till the 1970s, there was a difference between the quality and the strength and the properties of galvanized wire and bright wire. So the bright wire was stronger. Due to the galvanization, you ended up with wire which wasn't strong as the bright. But thanks to Vebināra from Belgium, this company invented, let's say, a way to do the galvanization so properly that you end up with the same qualities with bright and galvanized wire. Yeah. So afterwards you have the different types of wire on different diameters. You can do winding. So then we're going to make strands. So several wires will become a strand. And then with several strands, you do it in the closing machine. We're going to see it afterwards. And then you're going to end up with wire. That wire will be tested, and then it will be, let's say, on stock for our clients. That's the, let's say, the manufacturing process. Let's talk about some terminology. So this is, let's say, a wire rope. It consists out of several strands. You see there are 6 strands. Yeah. Every strand has composition of some wires. Yeah? And then you see in the middle a core. We explain what type of cores do we have. The wires in the stranded rope. You see the red wires there, they are the outer wires. So these are the wires which will be in contact with sheaves and with drums. Yeah. Underneath you have the inner wires. Yeah. So you see a certain construction there. Yeah. In the middle of every strand you have the center wire, which is important to, let's say, to withhold the whole structure. And in the core you have the core wires. Yeah, so that is, let's say, the terminology about wires. Okay, let's make wire rope. Wire rope is made in 2 steps. The first step is manufacturing of strands. So we do stranding from some wires to make a strand. And the second step is the closing of some strands to obtain a cable. We call this closing or cabling. You see on the left there, the whole drawing. You see the center wire in the strand, and then you have the outer wires in the strand, and then you see we have there some strands around the core, yeah, the closing. So we have in the end, we have the whole wire rope. Look at the different type of cores you can have. You can have a fiber core, let's say that's cordage inside your 6 strands, or you can have an independent core, so an independent little wire rope in the middle. Yeah. Okay. Step 1 is manufacturing of the strands. Well, traditional. This is at the left side. The most simple strand you can make. You just take 1 wire and you surround it with 6 wires. You can do even yourself and try to make this kind of construction with, let's say, some coins of money. And you can see that, yeah, you can surround it with only 6 and you have 7 threads, or 7, 1 plus 6. 7 wires in 1 strand. If in the same diameter you need a strand which is more flexible, yeah, then you can start with wire which is thinner, and then you add another layer, like you can see there, 1 plus 6 plus 12. You end up with a 19 threads or 19 wires in 1 strand. If that isn't flexible enough for you, okay, you can add another layer, and then you have 1 plus 6 plus 12 plus 18. That's 37 wires in 1 strand, and you can add up another layer. You can have 61. So more flexible every time you use smaller diameters of wire and you put on more layers. A disadvantage of this traditional construction is that if you bend your strand, you're going to see there are some internal crossings between the layers. You have point-to-point contacts, and this will give you an internal wear. You're going to have cracks, and this will deteriorate your wires. So this is a big disadvantage, yeah? And that's why they invented the parallel construction. You see, the parallel construction is that kind of construction where every wire is embedded in two layer wires, yeah? And if you bend that, you don't have point-to-point contacts, and this will give you a very flexible strand. There will be no internal wear, no crossover. So every wire is embedded and supported by two underneath, yeah? And to obtain this, we need to have another, let's say, construction. And I show you here some of these parallel constructions. The first one is called seal, and it was invented by Mr. Seal, Tom Seal. He invented the construction. You start with the inner wire, let's say, and you surround it by, you see, nine little wires in diameter, and then you seal it up with 9 bigger wires at the outer layer. So this is a 1 + 9 + 9 seal construction. And the advantage of this is that it's very flexible. You have the parallel construction, so no point-to-point contacts, and you have a very big wire on the outside, so you can have a very abrasion-resistant strand. There was a colleague, Mr. Warrington. He thought it's perhaps a better idea to put 1 + 6 and then alternatively thicker and thinner wire in the outer layer. That's what we called the Warrington construction. Somebody thought, well, let's just keep the old standard construction, but we're gonna fill up the empty spaces between the different layers, and you can see there are 6 filler threads in place there, and this is what we call the seal fill construction. Yeah? And then there was another very good idea to put the Warrington and the seal construction into one construction, and that's what we call the WS Warrington seal. What is it? Well, it's a combination of the Warrington. You see in the second layer there, you have alternating the thin and the thicker wires, yeah, in the layer, and then you seal it up with the thicker wires from the seal construction at the outside. And these are very common and very many times used in steel wire ropes. You're going to end up with 26 Warrington seal. If you start with 1 + 6 and then 6 thick threads in the Warrington and thinner in the Warrington layer, and you seal it up with 12, you count it, it's 31 Warrington seal. And then very common is the 36 Warrington seal, 1 + 7, alternating thicks and thin in 14, and then you seal it up with 14. That's what we called the 36 Warrington seal. So there is no wear inside, there are no crossovers, it's very flexible due to the combination of all these different thicker and thinner wires inside. The abrasion resistance is very good because you have the thicker wire on the outside, and this is a very good strand, okay? So that's what stranding looks like. You see, stranding. Later on, I'm going to show you a film where you can really see it in the manufacturing. And then step 2 is closing of wires. And closing the wires means you're going to take several strands and then you make your wire. Okay, let's go to the movie, I think.
Yeah. Please note that this movie has no sound. Ellen will do the voiceover with this one.
Yeah, okay. Well, steel wire rope. Step 1, as I explained, we're going to take some wire and we make it to a strand. So each wire is spooled on a bobbin, and these bobbins are placed in this kind of stranding machine. They can go up to 64 wire bobbins in such a machine. But normally it's very common to use 19 or 36 wires, bobbins, to end up with a strand. How many wires per strand depends on the job the rope will perform for different applications. We require different degrees of flexibility and strength. All the wires converge in a die, which form them to a certain diameter. As you can see, lubrication is added to this strand to move the wire smoothly through the die and penetrate within to allow slight movement between the wires. This will increase the lifespan of your strand and of the rope. The strand travels through rows of straighteners that will take away the stress. Here are these straighteners, let's say, to take away the stress, and your strand will become much flexible. Okay, step 2 is then we take some of these strands to make wire rope. So we put it in another machine, a bigger machine, you see, and that's what we call a closer. Here you see 6 strands will become 6-strand wire rope. And before the strands convert in the die, rollers pre-shape them into what you see here, a corkscrew-like form. That's what we call preforming. Yeah, the strands then enter the die, twisting together over a core. There you see the core, yeah, itself. It could be also a steel wire rope or another kind of core or strand. Then the wire rope travels over some calibrating rollers, which will correct the cable to the exact diameter, and it makes the rope again flexible, and then you can cut the rope without problems of opening it. Let's be clear about some lubrication you need. Well, normally we lubricate ropes between the wires in the strand, and sometimes, depending on the application, also between the strands. Well, you need some lubrication because it will have some loop for flexible stranding. If you don't add lubrication during your stranding, yeah, then you're gonna damage the strands, the wires. So you need, from the beginning, you need some lubrication there. Then second, you're gonna have conservation for the rope while it will be stocked at the manufacturer. Then it's gonna be stocked at Mannens, let's say, or at Certex, and then perhaps it's gonna be stocked at the client for, I don't know, months or weeks or perhaps some years. So it is a conservation lubrication, yeah? And then the lubrication will stay in your rope during your first period of use. The grease will disappear slightly in time, and then we advise to do a maintenance lubrication, so to prevent corrosion and to lubricate all different wires and strands by lubricating again with lubrication which doesn't fight or which doesn't put out the original. Yeah? So if you do maintenance lubrication, don't forget that you also lubricate your sheaves, your grooves of sheaves, and your drums. Yeah? And in global, we can say if you normally do maintenance lubrication, you're going to end up with 20, 30 or 40% of more lifetime on your rope. We're going to do a special seminar later on just for maintenance lubrication afterwards. Lubrication look like this. Yes? Let's say not grease, really not greasing anymore. It's oiling your rope. Coca-Cola-like spray, yeah, which goes into the strands, which go into the rope, hopefully till the core, and there you need your lubrication. Okay. So as you've seen, cabling or closing, we can put 6 strands around, let's see, in a wire rope core, so independent rope in the middle. Or you can put also fiber core, cordage in it. This fiber core can be, as you see on the right side, from natural fibers or man-made, like polypropylene. From natural fibers, it had the advantage that you could add some grease to an amount of 25% of the weight of the fiber core. Yeah, it was, let's say, a kind of lubrication which was in the core, and if the wire rope traveled through sheaves, then it was squeezed, let's say, and in time it could liberate a little bit of grease, so re-greasing the outer strands. This was an advantage, but anyhow, it is a disadvantage too. Once the grease is out, yeah, you're gonna have a sponge inside, which will take all the water into his core, and then you're going to have perhaps a corrosion problem. And anyhow, the rope with fiber core type, well, it has a longer elongation, and you can't use it in high temperatures because this is, let's say, a plastic core, so you end up with high temperatures above 100 or 120 degrees. It's going to be molten or something. So be careful with fiber core. More common is the thing you see on the left side. It's let's say a steel core, independent wire rope core, EWRC. This is a small independent steel wire which is in the core, which can also be a wire strand core. This is just one strand you put in the middle, and the last 30 or 40 years we have also a plastic covered wire rope core. This is a core which is plastified then, and then 6 strands or 8 strands are embedded in the core. It is not compressible. It can be used on multi-layers drums. It is less sensible to internal corrosion because you have a full metal. It increases the breaking load, and it has a lower elongation than the fiber core. If you use 8 strands to do the closing, then you have a much rounder steel wire rope. Like presented here, you can have 8 times 26 Warrington seal, 31 Warrington seal, 8 times 36 Warrington seal, and so on. Notice that you need to have a bigger and flexible inner core, and normally you're going to have, with 8 strands, you're going to have lower pressure because you're going to have more surface in contact with your grooves of sheaves and of drums. So there's going to be less pressure on your rope outer wires. So that means you're going to have less wear on your sheaves, drums, and wires. Rope. To show that we are not finished at 8 strands, you can have 7 strands, 9 strands, and even 10 strands outside, which makes a rounder rope, more flexible rope, stronger rope, so you can go to 10 strands. If you have 11 strands or more on the outside, then we speak normally about a non-rotating rope, and be careful because normally then the inner rope is the core inverted, and that's what we call the non-rotating or rotating resistant rope. We're going to talk about this kind of ropes in a special high performance wire rope seminar. It has typical applications for tower cranes, so high lifts, mobile cranes, and one part hoisting. Well, show you some applications, properties of these constructions. As you can see, the more layers, the more flexible and the more Warrington seal you need. Different kinds of wire diameters to construct your rope with. You see the seal construction with the thicker outer wires as an advantage. Disadvantage is it's a rather rigid rope, let's say. You see the Warrington, vulnerable at the outside because you have thinner and thicker wires. Filler wire with advantages that you have a more stable construction, higher breaking load. Disadvantage that these thinner wires are very vulnerable, let's say, and the thinner wires are not counted for your discard. We're going to see that later on in other seminars. And very common is the Warrington seal construction, very flexible, good resistance to wear. There are no disadvantages. Let's say you have all the advantages of the other ones. Of course, there is a higher price because you need to have different steps in stranding and closing. Yeah. Applications of steel wire rope. Well, I just put on some examples. Winches. You can use 6-strand ropes or 8-strand ropes, depending on the strength you need, the souplesse you need, the flexibility you need. Overhead cranes. You have 6-stranded, or if you want rope which lasts longer, rounder, you can have 8-strand ropes like presented there. For container cranes, we normally advise 8 times 25 with filler. Yeah, you can get it from 8 millimeter and bigger diameters. Look at the center core there. It's a complex center to have much flexibility, have long life. Elevator rope is 8 times 19 seal with fiber core. I don't know, but in Belgium it is still necessary to have a fiber core. All strength wires in elevator rope must be visible on the outside. Yeah. Okay, and then you have overhead cranes, mobile port cranes, offshore cranes. You can look at the website of Certex. And there you're going to be guided what kind of rope you normally need or we advise to put on your rope. At the right side, we have tower cranes, mobile cranes. This is the rotational resistance where the core is inverted. And there you're going to see at the outside 11 or 12 or till 16 or sometimes 18 outer strands on your outer layer of rope, but we come back on that in another seminar. Just explaining you now right hand and left hand ropes. There are left hand and right hand ropes, and so you do the closing right hand or you do the closing of the rope left hand. Why? What is the purpose of this? Well, let's explain first of all which is right and which is left hand rope. Look at the left, you're going to see the wires, the strands are going upwards to the right side. This is right-handed rope, regular right-handed rope. You see, if you look into the strand itself, then it's the opposite. You see that the wires in the strands, they are going up leftwards. So, this is what we call regular right, ordinary right and ordinary lay. Yeah? And the left-handed rope, you see the strands, they go upwards to the left side, and in the strands, the wires, yeah, go to the right. And that's called left-hand ordinary lay. Because Mr. Lang, a lot of names coming from persons who invented it. Mr. Lang, he invented the Lang or the long ray construction. And if you look closer, here you have the strands going up to the right-handed rope. But if you look into the strand, also the wires are going up to the left, to the right. So you have right. This is long lay or Lang's lay right. Same discussion with the left. You see left, and in the strand, the wires also go up to the left. What is the advantage of this? Well, you see that you have a lot of wire touching on the outside. So there normally has the very big advantage that your rope will not wear out easily. Wires will last longer. There's only one disadvantage, that you have to fix your rope on both sides thoroughly, because this wire rope would open up very easily if you turn it. And why do we need right and left-handed ropes? Well, I explained you this is a helix form in your 6 or 8 stranded rope. And if you put load on your wire rope, this will open up. That means that your load will rotate. Yeah. So the much bigger your load will be, the much bigger the rotation will be. So if you don't want your load to rotate, well, you're normally going to need 2 wires. You're going to need a left one and a right one, and you're going to have to balance it. So if you put in that situation now your load on the hook, then the left will have to open up on the left, the right will have a moment in the opposite, so nothing will turn. That's one of the reasons you need left and right hand, but you have also the drums, because the drums have a right or a left-handed pitch. And you need to have a certain left or right-handed rope on a right and left-handed pitch in your drum. It's depending on the deflection angles wire, rope will open up if you don't use the right or the left-handed rope. So in certain applications like baskets here or on overhead cranes, you're going to see that you need a left and a right-handed rope, which give no moments on your loads. And you see also on the right side there that you need left and right-handed rope because your drums are right or left-handed pitched. Yeah? So this is an idea where to put left and where to put right-handed rope, so take care. You can look it up on our website if you're not certain where to put it. Certain is if you don't follow this guideline, you're gonna always open up rope, yeah, and it is better to close up rope, yeah. So once time you opened up a rope, you're never gonna close it thoroughly again, yeah. Right hand and left hand. It's very important to have a good lifetime, yeah. Okay, here's some examples where to use right hand and left hand ropes. You see on the right, the right-handed rope on a left cutted drum, and then you have his sister rope, yeah, the left-handed rope, yeah. You see different drums there, and sometimes you have 4 ropes in left, 4 ropes in right to have the calibration, let's say, of the wires. Just some more information about how do you measure the diameter. Yeah, you have here, you always measure it with the biggest diameter. As you can see there, it's wrong. You have to turn your, what's it called? So to have the biggest diameter. Normally, you need to have a tension of 5% of the breaking load. This is not always possible, but this is, let's say, how it is prescribed in the norm. From 8 millimeter up in the norm now, there has a tolerance of -0 till 5%. Till 2010, the norm was -1 + 4. Of course, we from Certex and Manus, we couldn't deliver a rope which was -1%. So we were still always -0 to +4. But now, due to some ISO standards from China and Japan, it is now +5. Anyhow, our standard in tolerances for ropes, which we will sell you, or which Alain Bouwman will sell you, will be at +3.5%. So it will always fit on your existing sheaths and grooves. So take care, be aware of some manufacturers who could have a bigger diameter. This is a lay length. The lay length is one helix in a rope. It is normally, just to have an idea, 6 to 6.5 times the rope diameter for 6 and 8 stranded ropes. Yeah. Well, this was a first introduction for, let's say, standard wire ropes, 6-stranded, 8-stranded, and so on. And next seminar will be about special wire ropes. What is so special about special wire rope? Well, I'll explain it because there was from the 1970s very important inventions in steel wire ropes with, let's say, plastic infill between strands and core, compacted strands and hammered strands. I show you just to have an idea. What you see here is that the wire rope core is plastified, yeah, and then the 8 strands are embedded in this plastic layer. All the red thing you see there is plastic, so this will give internal wear reduced between the different strands, so there are no contacts anymore, so you don't have to care what is happening inside my steel wire rope core. It keeps the grease inside during your probably whole lifetime. So if you're going to be maintain your rope with some lubrication, you only need to grease or to oil the outer strands. Yeah? It keeps water or dirt out of your cable, so you don't gonna have a corrosion problem, let's say, and it's gonna increase the stability of the rope. If you want to open up this rope, yeah, the plastic will prevent for opening up, so you're gonna have a very stable wire rope. Yeah. The second invention they had is to do compacted strands. So first you make your strand, and then you're gonna become in a higher breaking load, more steel in a given diameter, because you're gonna roll your strand to a compacted strand. Yeah, it gives or stays with a higher flexibility. It gets lower stresses. You see, there's no more air inside. Yeah. Big advantage of this is that the broken wires, if you have a wire on the outside which is fatigued, yeah, then it will stay in your compacted strand. So when it travels to sheaths, then it won't damage its neighbors. So you're going to have one broken wire and that's it. If you still have round wires at the outside, yeah, then this round wire will flop out of the strand, and when it goes through your sheaths, yeah, it's going to disturb, let's say, his neighboring wires, and you're going to end up with one wire, and after some days with several wires and so on. If you have multi-layer ropes on several layers on your drums, you're not going to have this knotting problem between ropes, so it's going to be very smoother. So it is done like this, so you have your round wires becoming in your strand to a very smoother surface. The whole of your wire rope will become rounder. There will be more touch in touch with your sheaths and with your drums. And then the third thing is rotary switched ropes. You're going to hammer these ropes to become more round again. So especially for multi-layer windings, and the cable becomes more even robust, and you're going to have more steel, let's say, in your cross section. But this is a special webinar for high performance steel wire ropes coming up. I don't know, we're going to ask Michelle.
Somewhere in June.
Yeah. Yeah, okay. But you are invited to come and listen to that upcoming webinars. There will be other webinars, inspection of wire ropes, discard, magnetic rope testing, interesting for everybody, I think. Very important for your lifetime, the rigging arrangements. We're going to talk about sheaths, drums, blocks, lubrication of wire ropes from the beginning, or maintenance, and there'll be a whole seminar of different end terminations also. That's it for what I had to say today. Thank you for your attention. I don't know if there are already some questions, but
thank you very much. Yeah, you managed to have more than 230 people watching at the time.
Very
so
nice.
It's very, very good. Some questions that I've published. A question from Vebināra. In a pulley, what is the hardness required to pulley surface?
Yeah.
Friction pulley, I mean. Okay.
Yeah, well, As I explained, you have tensile strengths of wires. This will end up in a wire rope, which has a certain degree of hardness at the outside. Yeah? Now, this hardness, you can't measure it. You can't measure it with a certain device. We normally speak about hardness Brinell. Yeah? You have Vickers, Brinell. But if you could measure it, and we know what the hardness of a wire rope at the outside will be, it's going to be about, if it is 1770, it's going to be about 500 hardness Brinell, HB. Yeah? If you're using wires at the outside of 1960 Newton, it's going to be about 600. And if it's Brinell, and you end up with 700 or more Brinell if it's tensile strength of 2160. So this is very hard. Yeah? We propose, or we advise, to have half of these hardnesses to have hardness in your grooves of sheaths and in your grooves of drums. So if you take the middle tensile strength, let's say 1960, you're going to have 600 Brinell for your hardness of the rope. You just divide it by 2, and then you're going to need, or I'm going to advise always 300 hardness Brinell to have as the groove hardness or the groove hardness on your drum. And then normally you won't get any negative imprints. You don't have big problems. You're not going to have big problems with sheaves and with drums. I hope this was
I think that was a good
But
answer.
we're gonna elaborate on that later on when we talk about drums and sheaves. So which hardness we would like to have.
Okay, I do 2 more questions before we need to close this one. Some ropes are in straight form when first unwound from the reel, while others are in the wavy form. These products are of Western origin. Is it a problem that the rope is in wavy form when it's first unwound?
Well, sometimes people ask me, we need non-tension, non-torsion rope. Well, every rope has to be non-torsion. I mean, if you pull your rope from the bobbin, it has to be straight. Yeah. If the rope is not straight when you pull it from the bobbin, what happened with that rope? It has to be straight. Yeah? The rope itself, had a helix form, but the rope must be straight. If you put it on the floor, it has to be straight. Yeah? Some people say we need non-rotating rope. Non-rotating rope, I explained it, this is due to the inverse core. This is completely different. But every rope which you buy or you could purchase at Certex or at Manners should be a rope which is straight. Yeah? And if it isn't straight, then there is already a rotation in the rope. Yeah? And where does this rotation come from? It can be introduced when somebody bobbined from one to the other bobbin to cut your rope, and then you have a rotation. This means that from the beginning, your rope will have a rotation. It will be on your crane, and it won't fit, let's say, it won't last long. So it is very important to have a rope which always is straight. Yeah? It could be a problem from rolling it to other bobbins, or it could have been a problem by installing it on your crane. But every rope has to be straight to be mounted on your installation. I hope this is what
I think so. Otherwise, we're going to have a re-question. But I'll do another one. Is it allowed to calculate with the actual breaking load instead of the minimum breaking load?
No. No, you always need to calculate with the minimum breaking load. Every rope has a minimum breaking load. This is explained in a lot of tables. You can look up in the normation sheets from ISO or NAN. So you just look it up, and there we see that for the 30 millimeter in that kind of rope, with that kind of core, you're going to end up, I say, 20 tons. This means that every manufacturer which makes a 20 millimeter rope in that type of rope has to have a minimum breaking strength of 20 tons. The problem is, if you're going to test this rope, well, you're going to have different kind of testing results. You're going to have 20.5 tons, perhaps 21 tons. The more you test, the more different kind of actual breaking loads you're going to have. And then you can add this up and you have a number, let's say, you divide it by the tests you did, and you said, yeah, we have a middle actual breaking load of 21 tons. Yeah, that means if you do another test, it's going to be higher or lower. So to have only the exact breaking load, you have to calculate it on the minimum breaking load. So minimum breaking load, there you add up your, take an account of your, let's say, safety factor you're going to use. Normally it's going to be 5. Take care of your losses you're going to have with your end fitting, and the end fitting will give you 10 or 20% less strength because on that particular spot you don't have your minimum breaking load again. So add this up, but always calculate with the minimum breaking load. The minimum breaking load will do the job. Yeah?
Okay, let's do a final question, and the other ones will be answered after. But we'll do a final one because of the time, of course. You have recommended to lubricate the contact surface of the sheaves. Is this correct? So lubricate only the rope is not enough?
The rope itself has his lubrication out from the factory. Yeah. So this will stay in the rope for, let's say, on your application for the first months, years sometimes. Yeah. So your rope will become dry. Yeah. And this old grease will stay in the grooves of your drums and of your sheaves. Yeah. So it will drop down or it will come down, and then afterwards you're going to have a dry rope on a dry groove. Yeah? So then you need to take some action, and then you have to do maintenance lubrication. So a lubrication which will get into the rope, into the strand, yeah, which will do the job that every time you bend your strands, you bend your rope, there is a slight movement from wires against one another, and then there will be no abrasion, let's say, in your rope. But if you're gonna lubricate your rope again, you're gonna have at the surface of your rope also lubrication. So it is very important to have a little bit of lubrication also in your grooves. Yeah. So this will end up with a longer lifetime of your rope, but take care also of your installation, also of your drumming and of your sheaves. It's very important to do because changing sheaves and changing drums will be much more expensive than changing the rope. So don't say leave the rope till the end, till it's dry, and it's not interesting anymore because we're gonna dismount this rope in 2 or 3 months. The 2 or 3 months it is running dry. Take care. Then you're gonna have these, let's say, dry on dry surfaces, and then it's gonna wear out your grooves. So don't be keen on not lubricating again because you're gonna throw the rope out of the installation. Then perhaps just easy lubrication, spraying an oil, typically oil for steel wire ropes. You can use a lot of lubrication, but we have a special seminar coming up for re-lubricating ropes. Yep. With lubrication, especially, let's say, created for steel wire ropes. You can use it on your bicycle also, but it is foreseen on steel wire ropes. Yeah, and this will come up in next month. Yeah. Okay.
All right. Time's up, unfortunately. You could talk for hours on steel wire rope. Thank you very much for participating. Like Ellen said, the next webinars will be communicated soon, the new dates, and please fill in the evaluation form which is in the chat if you are able to. All the other questions will be answered directly by one of your local companies, specialists, and of course we will share the record of today. So again, big thank you to you, Ellen. Big thank you to you for participating, and I hope you know more about the basics of steel wire rope.
Always at your service.
Thanks. Bye.
Bye.